Okay, I'm back, and I promise this time I'll have better handwriting. So this time, alright, we got cubic roots. Now, the first question, right? Also, I'll disclaim that all of these should be done by hand. That's kind of the nature of my class here. But anyways, first we need to find the cubic roots of this. And to find we need to first convert this into the Cartesian form, into the cis stuff. It's pretty easy. So R, right? It should look something like R cis theta. R can be figured out by finding the square root. Oh, I need the Pythag of these. So it should look, no, I'm just gonna do it anyways because this plus this. Okay, that should give us 2, 6, 8 root 8. And the theta is the arctan of the imaginary number, so negative root 6 over negative root 2, which should equal to, or it should equal to, let me check this real quick. Okay, I mean, if we follow conventions, right, something like this. Okay, this equals, by the way, this equals to negative root 3. Okay, just positive root 3, I hope you know that. So now you know it's positive root 3, we can do the special triangle stuff, okay? And I'll tell you why this doesn't work just yet. Okay, so it should be it should be this, okay, so it's pound 6. Oh, 3, if this is, oh, it should be pi on 6, okay? Using special triangles. But the reason why it's not pi on 6 is because, see the top and bottom is negative? Then that means it's in the third quadrant. Why? Top is y-axis, it's going negative. Bottom's x-axis is also going negative, so it's in the third quadrant. And we all know in the third quadrant you minus pi, and the second quadrant you plus pi, you do nothing here, okay? So you minus pi here, which will give us negative 2 pi on 3. Something like, oh, this should be pi on 3. My fault. Okay, and why? Because, oopsies, it looks like this, right? Oh, 3, 3, and 1, boom. So it's pi on 3 minus pi, and then you get negative 2 pi on 3. Easy. I did promise I'd do better handwriting. What is this garbage? Anyway, so we know that's the angle. Cubic roots, okay, easy. First, we need to understand that W1 should equal to root 8 to the power of root 2, root 3. No, root 3, what am I talking about? I'm tired. To the power of 1 over 3. And then it should be cis, what's the angle? Negative 2 pi on 3 times by 1/3. And by the way, root 8 to the power 1 over 3, if you just do some simple stuff, right, this is the equivalent of this, something like this. 3 over 2, it should be times 1 over 3, and then you do that, blah blah blah, it should get 2 to the power of half. But anyways, it should look like this, and this should be negative pi over 9, 2 pi over 9, which is what we got for the second, right? And just remember this is from smallest to largest, so that's why it's in the second part, because we haven't done the rest. So you need to keep continuing doing this, the W2. The trick here, though, is you don't actually continue to times by 1 over the third. Yeah, you've already done that. What you need to do is you need to understand we need to, from negative 2 pi on 9, add 2 pi on 3. The reasoning behind this is because to find this number, alright, we're doing, what root are we doing? We're doing cubic root, so that's 1/3. And that's 1/3 of the circle, okay? So one circle is 2 pi, and you divide by 3, okay? Don't ask how that works, I actually have no clue. So once you do all that, that should give you 2, and then it should give you, yep. I just said yep, because, I always add, by the way. I just said yep, because I actually have not a single clue right now. Oh, it's 4 pi. 4 pi on 9, so right here, okay? To find this very last one, is something you might not realize, is 3 equals 2 half cis. What do we say for that one? 4 pi on 9 plus 2 pi on 3. This will equal to, alright, this will equal to something very crazy, 10 pi on 9. Now, what do? We minus 2 pi to put it back in between principal argument, which is negative pi to pi, right? Your angle has to be between this range. So then once you do this, alright, which is going to be a crazy number, psych, negative 8 pi on 9, which is the smallest number, so we've just figured it out. Now, if you're here worried about, oh, bro, Addison, you said W3, W2, W1, now we're just mixing it around, so does math even matter anymore? Well, listen, okay, I don't even know what W stands for. W probably stands for winner. Why am I doing this? It probably stands for why do I make these very shit videos? Who knows? To help people who's like me. But anyways, they even messed up here, like, I don't even know what that means, why they're on 1. Alright, doesn't matter, just, it says smallest to largest, make sure it's in principal argument as well. So, yeah. But the second question is a bit of an interesting one. Alright, this is more algebra. So let's figure this out. Essentially, okay, these equal the same thing. Okay, why am I saying that? Because I'm trying to tell you, you don't need to put 3 over here. You don't have to do all that bullshit. It might work. Alright, who knows? Okay, but it's also a good thing to notice that I squared equals to -1 because I equals to root -1, which doesn't exist, but it's an imaginary number. So who knows? So congratulations. You're on the second question. What do you do? Alright, expand it. Whoa. Alright, okay. Let's do this. Well, what is that? So 2x and then plus xi. Let's just do something more fancy. Ix minus 2i minus I squared. Okay, happy? Happy. I'm happy. So now let's segregate the real to imaginary numbers because, I mean, come on, this is real, this is imaginary, you know the drill. So, okay, it's 2x plus Oh, never mind. It's just 2x, it seems. Oh, no. This converts to positive 1, by the way, because I squared is negative 1, and is a minus, that's positive 1. So it's 2x plus 1, okay? And then, you got ix minus 2I. Those are the two imaginary numbers. Take the I out, right? So this is still plus, by the way. Take the I out, so it looks like x minus 2I, okay? If you don't know how I got here, then I don't know, man. I don't know what can help you. But essentially, factorization, just honestly, you can even chuck in a calculator. But in the case of an exam, be tech-free or unlucky. So, 2x plus 1, okay, now you got it. Your real numbers should equal to this real number. Your imaginary numbers should equal to that number. Now you know that. 2x plus 1 should equal to 3. Okay, x equals to 1. X minus 2 should equal to negative 1. Oh, whoops, sorry. Negative y. Okay, we found out 1. X is equal to 1. 1 minus 2, negative 1. Y should equal to 1. So, x, 1, 1, 1, y, 1. Okay, boom. Too easy. Third question is the simplest of all. Please do not stress when you get these questions. This refers to this. This refers to this. This refers to this. If you don't have any idea what I'm talking about, I'm going to do a quick run through, okay? I is the x-axis, J is the y-axis, K is like the pretend. Okay, I'm going to draw something that makes more sense. Okay, this is like a rectangular prism, okay? I and J pretty much is the two-dimension, 2D. Okay, so this is the I, you know, we're going up, X, oh my, I'm actually so stupid. I is the x-axis, Y is the j-axis, okay? Not too deep, right? This is 2 dimensions. Then when we introduce K, we get into the 3-dimension, it goes up. Now, what does this even mean? Like, Addison, I don't get what K means. And if you do know, then please skip the video, but I didn't know what it meant at all. So, I'm gonna do something for you guys, okay? What does IJK mean? Vectors. What is it? So, I'm gonna start very simple first. This is a normal arrow, right? Basically, these vectors, all it means is we need to look at what makes up this arrow that goes this direction, okay? So we're like, okay, well, in this case, it's going this much. Oh, yellow is such an ugly color, but yellow people are the best because I'm yellow. Okay, so it goes this much x, this much I, and then it goes this much j. Is that right? Taking my vectors right? Yeah, yeah. It goes this much j, and this is your vector. There you go. That is your precision vector, whatever this is. Okay. And when we introduce k, all right, let's see. Let's show you a picture. Best. So, okay, let me show you a picture right now. See this one? Perfect. See? You see this massive green arrow? You know how it's pointing outwards in a 3D runway? Let's say it looks like this, okay? So this, oh, I need drawing lessons for real. Okay, so this is your, don't worry about it just yet, okay? I'll go deep in depth, okay? Boom. Okay. This is very complicated, but I will guide you through because I am crazy. Okay, so imagine this is your x-axis, so your I. This is your y-axis, y. So you can imagine that. Oh, j. You can imagine that, right? See how it's like kind of like a rectangle like this, right? And then there's also this is your 3D shape now, right? This is your k. Is it k? It is k. Okay. Now imagine there's an arrow that's going straight out like this. Okay. You saw that diagram. Remember that diagram? Imagine this is pointing out. And this isn't on this plane, by the way. It's pointing fully out. So there's like this. There's like a whole ass triangle here. Essentially, alright, K is saying how much it goes up, I is saying how much it is going towards I, J is how much it's going towards that direction, okay? And that is essentially what IJK is. It's basically a vector. The whole entire premise is seeing an arrow and seeing how much it is made up of IJK, and the X, Y, and the 3D thing. Now, what is the question asking? Okay, it's the directional angles. Now, directional angles is very simple, alright? We know that alpha equals to the angle of I, the beta equals to the angle for J, and the gamma that's gamma, right? I'm an alpha, by the way. This is me. Okay, just want to put it out there. But you know what? No, my fault. This is you guys, and I'm the beta here. That means I'm a bitch. Now we can all be here. Okay, I'm actually getting way off track. This is the curve. I got the K. And the directional angles is very interesting because essentially what it's asking for is what's the angle it's making with the directional vector right here. So essentially what that would look like is, so for K, right, the gamma would be like from there to there, right? For I, it would be from here to here. Wait, from here to here. Right, because just imagine like the arrow, right? It wouldn't make sense if it's going to there, because this is literally levitated up by like, I don't know. So it's going to be up to here, and J is the angle from there to here. Okay, it's from here to here. I mean, it's pretty complicated if you think about it. But if this makes more sense than your lecturer than W's, I didn't even know this, to be honest. My lecturer taught me. So shout out to Keith from my 1090 class. He's a real one. So this is how it works, okay? And the formula is as follows. So simple, right? So simple. Cos alpha. By the way, this is like 3 variations, okay? Because obviously it's asking for three. So as you can see, it's asking for 3. So what it's asking to? Cos alpha, a over vector. A is essentially your coefficient behind I. So I is -1 then in that case. So that's just -1 over vector. I'm gonna teach you how to calculate this as well. Now, you see V is literally the arrow, right? Super easy. Massive Pythag. Massive. Okay? And you literally just do that ugly color. The coefficients. Okay, so the coefficients of each one. So this is the coefficient for I is -1. Coefficient for this is negative root 2, and this is positive 1. Okay, and now we've got that in our head. -1 squared plus root 2, negative root 2 squared plus 1 squared, which would equal to 2 because easy. That's 1, 2, 4. What's the root of 4? Oh my god, it's 2. So essentially, this whole equation right here will equal to -1 over 2. Now I'm about to show you how to actually find everything else, right? So I mean, everything else is pretty straightforward. I'm not going to go into it because I mean I can't be asked. I still have so much more to study. It's literally 11.5, but it's just B is just negative root 2 over 2 because we just found out v is 2, right? And then same thing, it's just equal to 1 over 2, okay? But we're not finished, right? Because we still haven't found gamma because we need to find the inverse as well. So the inverse of, so to continue this, okay? So it's cos alpha equals to -half. How do we figure this out by hand, okay? So cos, inverse of cos, I don't know what that is, cosec or something? I don't know. Okay, how do we figure this out? Now, I figured this out 2 seconds ago. My guy on YouTube called Brian or something, Brian McDonald, I don't know. He legit told me this something very easy, okay? So let's imagine a fat circle. Let's grab a circle, shall we? We fancy like that. Okay, let's go. Circle. Yeah, that's pretty bad. Okay, and this is your x and y coordinates. Alright? And forget everything about the 3D bullshit thing, okay? Sorry, that's for because this is a completely different equation. We're just figuring out this algebraically. Whatever, I don't know. How do you figure this out? So, very simple. Okay, this is, from there to there is around pi over 6. This to here, from here to here, oh, let's draw it. You know what? We fancy. You fancy, huh? You fancy, huh? Pi over 3, pi over 4, alright, because I don't know, that's too much to explain. And from here to here is, now this is not to scale, okay, so this from here to here is pi over 3. Now, is this hard to remember? Probably not, especially if you've done like special triangles your whole life, like these are the 3 main angles, and it's pretty simple anyways, so you need to memorize this, okay? Just remember that there's 3 that like that, okay? Now, the very important thing you need to remember is these coordinates. Now, why? Okay, let me teach you, my friend. This coordinate, these are all divided by 2, right? Why? Honestly, don't question it. This is literally a blessing in disguise, right? If it was anything else, I'd kill myself. And this shout out to Mark from my 1090 class as well, who's my friend, and he literally told me this. Anyways, as you can see, right, it's 1, 2, root 2, and root 3, and 1, root 2, and root 3. Now, how do I know this? Well, I did it. That's funny, because I just knew it's 1, 2, 3, and 1, 2, 3. Literally, 1, 2, 3, and 1, 2, 3. How can you forget that? The only instance I might see you forgetting is like the other way around, but come on, my friend, alright, just 1, 2, 3, 3, 2, 1. Right? If you ever forget, then just remember that this point is around half, because this is 1, right? So this point is half, and this is the x-axis, y-axis, so this must be half. Right? There's no way that this is half, because this should be neither one. So that's how you should know. I just had a thought. Okay, I think did I mess up here? I did it right. Okay, this is correct. Okay, oh, it doesn't look to scale for some reason, because I just realized like if this is 3, this should be like all the way up here. Oh, you know what? Okay, sorry, I'm questioning it too much now. This is correct. Okay, so let's look at this point. Cos inverse of cos -half. Well, now so clearly the cos here is negative, right? So where is cos negative? Okay, so if you look at the unit circle again, it's all schools take coke. Okay, so this is when it's positive, cos is positive, but it's negative in these quadrants. Okay, okay, and the video I watched that explained this was like, well, look, if it can't be in this quadrant because literally this isn't a function, right? Because it doesn't apply to the vertical line test. Why does that matter? I don't even know. Alright, but let's work for us. So it's in the second quadrant. Okay? We'll do a different color this time. I'm back by the way, my headphone came back. Like this, like this, like okay, you know what? It doesn't even matter. Look at what are we looking for? Half, okay? This is the half we're looking for, alright? Because look, this is what it is, okay? So since it's a half, wait, why is it like that though? Okay, because it's cos inverse half. Alright, we're looking for the output. Why is the output? Boom. So it's pi on 6. Okay, W's. Is it really pi on 6? There's no way. Yo, I'm actually throwing here. It's x-axis. We look at the x-axis, alright? This y-axis doesn't matter. We look at the x-axis. So, half it. Okay, right here. There. Something like that, okay? And this would be, oh, fair enough. This is the only negative half here. And how do I know it's negative? Oh, well, because actually, guys, this is the negative x-axis, positive y-axis. So this coordinate must be negative half, root 3 on 2, okay? Now, so the answer is root 3 on 2? Nah, Kilius, you got trolled. If this is pi on 3, remember, the Cartesian plane doesn't work like this. It's not pi on 3. It's from this point to here, right? Come on, guys, you know better than that. So that is clearly 2 pi on 3. Oh my goodness. So the angle for alpha is 2 pi on 3, which is correct. Correct window. And the reason why I showed you all this is because a lot of us has to do this by hand. Okay, so if you don't know this, you are actually going to fail. This was probably 20 minutes.